Good morning, friends. So myself, Dr. K.R.K. Prasad. So now we'll discuss about some objective bits on Unit 1. See, here, what are the active elements? Active elements are nothing but delivers the energy to the outside. So what are the examples for active elements? Voltage and current source. Voltage and current source. Next, passive elements, which absorbs energy from outside. So what are the examples? Resistance, inductance, and capacitance, RLC components. Already we discussed in our previous videos. Directly I gave the conclusion regarding bits. So in examination, uh, in mm, in which way he can ask example of active element? Voltage, resistance, inductance, capacitance. Which one is correct? Voltage. Example of passive element: voltage, current, resistance, both A and B. Which one is correct? Resistance. Similarly, bilateral elements, RLC components. Unilateral elements, example, diode. Okay, so these are the different types of elements. So coming to unit, what is the unit of voltage? Volts. Current, ampere. Resistance, ohms. Inductance, Henry. Capacitance, farad. See, inductance is L, capacitance is C, resistance is R. But inductive reactance, JXL. JXL is equals to omega L, J omega L. Understand? What is the unit of inductive reactance? Ohms. What is the unit of capacitive reactance? Minus JXC, ohms. XC equals to 1 by 2 pi f C. So, omega C minus J by omega C. So, ohms. Next, real power. What is the unit? Watts. Reactive power. Reactive power is also called as imaginary power. What is the unit? Volt ampere reactive. Var. What is the unit of apparent power or resultant power? Volt ampere. Apparent power or resultant power? Volt ampere. Means I square R. Real power. I square X. Apparent power. Sorry. I square X. Imaginary power. I square R. Real power. And this one is VI. This one is apparent power. This is also called as resultant power. Resultant power. So what is the unit of real power? Watts. What is the unit of imaginary or reactive power? Var. What is the unit of apparent power? Volt ampere. Apparent power? Volt ampere. Apparent power is also called as resultant power. Imaginary power is also called as reactive power. Reactive power. So the angle between real power and apparent power is nothing but real power is representing with P. Reactive power is representing with Q. Apparent power is representing with S. So angle between P and S means real power and apparent power is nothing but power factor angle. Power factor is cos theta. So here theta is nothing but angle between P and S, means real power and apparent power. So this is called power factor angle. This is called power factor angle. So power factor can also defined in between resistance and resistance. This is JXL. This is impedance. So angle between R and impedance. Angle between theta is nothing but angle between R and impedance. This is also called perfect triangle. So what is the perfect triangle? Angle between real power and apparent power, or angle between resistance and impedance. Or else, if you take voltage and current, so angle between V and IA is also known as perfect triangle. So how you can define perfect triangle? Which can be defined with respect to powers, with respect to impedance, with respect to voltage and current. With respect to voltage and current, angle between voltage and current. With respect to resistance, ohms, angle between resistance and impedance. With respect to powers, angle between real power and apparent power. So this is nothing but power factor angle. So how you can define power factor now? So cos theta is equals to, tell me from this, P by, yes, from this cos theta equals to R by Z, from this angle between voltage and current, V by, clear? So these are the different topics. Next, power factors. If you take pure resistor, unity power factor, how you can tell? For pure resistor, angle between V and I is 0. Theta is 0. If theta is 0, cos theta is cos theta is 1. That's why it is unity power factor. Suppose if you take pure inductor, JXL, pure inductive reactance. So what is the angle? V is lags behind I by 90 degrees. So theta is 90. So cos 90, 0. That's why 0 power factor. Here current is lagging voltage by 90 degrees. That's why 0 power factor lagging. Minus Jx. Here voltage, current is leading voltage by 90 degrees. So theta is minus 90. Cos 90, 0. That's why 0 power factor. But current is leading the voltage by 90 degrees. That's why it is 0 power factor leading. Power factor value is 0. But it is leading. That's why for inductive reactance, it is lagging. Current is lagging. For capacitive reactance, current is leading. Suppose if you take combination of R plus JXL. Now, voltage, current lags behind the voltage by some angle. Not 90 degrees, not 0 degrees. Some angle. So that theta is in between 0 and 90 degrees. So that cos value, cos theta is varying in between 0 and 1. That's why it is lagging power factor, not 0 or 1. Simply lagging power factor. R minus JXC, this one is same thing, leading power factor. Suppose if you take combination XL minus XC. If XL is greater, if XL is greater than XC, now it is positive. So R plus JX. R plus JX is nothing but this one. So lagging power factor. Suppose if XL is less than XC, means this one is less than XC. XC is dominating, means resultant is negative. Negative means it looks like resistance and capacitor combination leading power factor. Suppose if XL equals to XC, means these two will get cancelled. There is having only real term. That's why it is unity power factor. So real means this one, resistance. So this is about different power factors. Okay. Next, superposition theorem. See, superposition theorem, it is valid only for linear and bilateral networks. Linear and bilateral networks. So what is the linear? Y equals to mx. This one is linear. Y equals to mx square. This one is parabola. Parabola means non-linear. Means y is directly proportional to x, linear. Y is directly proportional to x square, it is non-linear. Means suppose if you take v equals to IR, R is linear. Similarly, v equals to L into di by dt. L is linear. V equals to 1 by C integral I dt. C is linear. So here RLC components are linear. But coming to power, it is non-linear. Why? Because P equals to I square R. This is square term. Means power is directly proportional to square, which looks like parabola. Means non-linear. Or P is directly proportional to V square. Means P equals to V square by R. So this one is non-linear. This one is non-linear. So what is the example for non-linear element? Power. Linear element, all these are linears, RLC component. So this is about superposition theorem. There is a chance to ask the questions. So coming to AC circuits. See, here peak value. Peak value means if you take sine wave, this is maximum value. Let us 10 volts. This is minus 10 volts. Let us take. So from this peak value means maximum value. Peak value is nothing but max value. So from this, what is peak value? Peak value is 10 volts. Next, find out peak to peak. Peak to peak means peak to peak means 10 minus 10 means 20 volts. 20 volts. Next, average value. V average. So let us 0 pi 2 pi. So what is the V average? Take for a half cycle. Because for full cycle, average value is 0. So what is the formula? 1 by t integral 0 to t v of t dt. This is the formula. So for this, how you can write? 1 by pi integral 0 to pi vm sin omega t dt d omega t. So how you can rewrite this one? Vm by pi sin omega t means integral sin omega t minus cos omega t. So 0 pi. So cos pi minus 1 minus 1. So 2 Vm by pi. 2 Vm by pi. Similarly, you can find out RMS value. RMS value is VRMS is nothing but take mean, same thing. 1 by pi, 0 to pi. Next, Vm sin omega t d omega t. Take square d omega t. So, if you can do, you will get RMS value. You will get RMS value. So if you know average value and RMS value, you can find out form factor and peak factor. So what is form factor? What is form factor? Form factor is equals to tell me, form factor is there is having RM. So first take RMS value. RMS value. Okay, peak factor. Peak factor. So peak means maximum. So maximum value. Okay. And so maximum value by RMS value and RMS value by average value. So this is the form factor definition. How you can remember? There is having RM. So first come RMS. Peak. Peak means maximum value. First come peak value. So by default, in both definition, you should have RMS value. So automatically denominator, you should write RMS value. And another thing, average value. So already you know average value of sine wave, average value of sine wave and RMS value of sine wave. So already we found average and RMS values of sine wave. So what is the average value? What is the average value? What is the what is the average value? Average value is nothing but already we found for sine wave. Average value is 2 Vm by pi. RMS value. What is the RMS value? Find out, calculate. What is the RMS value? RMS value of sine wave is equals to Vm by root 2. So, what is form factor? Form factor is equals to RMS value by average value. Means Vm by root 2 by average value. 2 Vm by pi. Vm will get cancel. Pi by 2 root 2. So if you solve, pi means 22 by 7 into 2 root 2, 14, 22 by 14 into root 2. 1 by root 2 means 0.7 something into this one is approximately 22 by 14. Otherwise, 2 into 11 by 14 root 2 something. If you solve this one, you will get form factor value. You will get form factor value. Do it. Anyone can tell? So if you do, it is approximately equals to 1.11. It is approximately equals to 1.11. So coming to peak factor. Peak factor is equals to maximum value Vm by RMS value Vm by root 2 means 1.414. 1.414. So from this, what you can give the conclusion? Average value is equals to 2 Vm by pi. RMS value is equals to Vm by root 2. This is for sine wave. Sine wave. And form factor, form factor is equals to 1.11 and peak factor is 1.414. So these are the final conclusion. These are the important bits. Okay. So this is about first unit. And in the next video, we will discuss about second unit bits. Thank you.